simplifying radicals. We're starting a new unit, and that unit has a lot of information in it about square roots. So there's a whole bunch of vocabulary here today that I need to go over with you, and some old-fashioned or old-school algebra. Okay, so a radical. What is a radical? Well, you can think of radical as something crazy, right? That's the way you normally think of it, a radical. Well, it's sort of the same in numbers. You have rational and irrational numbers. So here's an example of a rational number. Rationals would be 2, 7, negative 9, 1.5, 7 over 3, etc. Rational numbers can be represented as a fraction. So any number that you can represent in a fraction is a rational number. So 7 can be represented as 14 over 2. 1.5 can be represented as 3 over 2. So those are rational numbers. Root word ratio, which means fraction. So a rational number can be represented as a fraction. Irrational numbers can't be a fraction. So things like square root of 2, which is 1.414 forever, or square root of 7, or the square root of 11, or the square root of any prime number for that matter. Now, another famous irrational number is pi. So another famous irrational number is pi. So rational numbers can be fractions. Irrational numbers can't be fractions. That's really the beginning here. So if you can remember what rational and irrational numbers are. So the second piece of information here that we're going to look at is what is a radical? Well, a radical is really just a symbol like a root. So when you see the square root symbol, which is what we're going to focus on today, that, folks, is a radical. And radicals can produce rational numbers or irrational numbers. So, for example, the square root of 9 is 3. So that produces a rational number. However, the square root of 5, 2.24 something if I remember right, that produces an irrational number. So you might be wondering right now, or I hope you're wondering, why some numbers will generate, some square roots or some radicals will generate a rational number and some won't. Well, that's because when numbers that are inside a radical are what we could say perfect squares, then we're going to generate a rational number. So for example, square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5, and so on. So these numbers right here are considered the perfect squares. Okay, the square numbers. And so 4, 9, 16, 25, 36, let's write them down, 36, 49, 64, etc. Okay, so now we've got ideas about rational and irrational numbers and what a radical is and what perfect squares are. So let's start by what's called simplifying, or actually not really simplifying, but we're going to represent whole radicals as mixed radicals. And here's the way it works. So the first one is going to be square root of 18. Square root of 18. By the way, this whole theme is about representing numbers in exact values, not decimal values. And it's a really important part of university pathway math. So it's not something you would do in 11M very much, if at all, but it's a big part of 11U and 12U, calculus and on to university. Okay, so this is called, right here, a whole radical. And that's because the whole thing is under the radical sign. So it's a whole radical. Everything's inside. The whole number's inside the radical or the root sign. Remember, this thing here is a radical sign. And specifically for us, it's a square root radical sign. So we've got square root of 18. Well, what we want to do is represent it as a mixed radical by taking something outside the radical and putting it out here. So what we're looking for factors of 18 that are perfect squares. Okay, remember our perfect squares. We should list them all the time. 4, 9, 16, so on. So are any of those a factor of 18? Check. So what we do is write this. Square root of 18 equals square root of 9 multiplied by the square root of 2. And you always put the perfect square first. So square root of 18 is the square root of 9 times the square root of 2. Remember, when there's nothing in between, there's right there, it just means multiply. So square root of 9 times the square root of 2 is equal to the square root of 18. But is there something, can we make this simpler? Square root of 9. Is that a perfect square? Yeah, it is. Square root of 9 is 3. So we can say now that square root of 18 equals 3 root 2. And that's called representing a whole radical as a mixed radical. So specifically, you've got a 3 there, or sorry, 18, it's a whole radical because the entire number or the whole number is inside the radical. This is a mixed radical because it's mixed between a whole radical underneath here and then this number out here. Okay, this number out here. So we've got whole radicals as mixed radicals. Let's try one more here. But sometimes we can actually put numbers outside. So I could have 5 root 48. So how would I do this? Well, I'm looking for, this 5 outside means 5 multiplied by root 48. So that's already a mixed radical. But what I'm supposed to do here, so I've already got a mixed radical. But what I want to do is get anything else out from under, I want to get as much as I can out from underneath that radical sign. So any square factors have to come outside. And that means it's simplified fully. Okay, so I want to simplify it fully by taking any square factors out of that. So 4 goes into 48. Let's see, let's try that. So I've got 5 times y root 4 times root 12, because 4 times 12 is 48. Okay, well that would equal, square root of 4 is 2. So 5 times 2 is 10 root 12. Are there any square roots left in here? Are there any square roots left in here, or any perfect squares rather, inside that? Well, what are the factors of 12? 1 and 12, 2 and 6, 3 and 4. 4 is a perfect square. So I've got to break that down now. So I'll make that 10, but then that becomes root 4 times by root 3. And we know that root 4 is worth 2. So 10 times 2 is 20 root 3. So that means that 20 root 3 is equivalent, it's an equivalent representation to 5 root 48, but it's fully simplified. Okay, it's fully simplified. Okay, so that's how you simplify radicals. So what we're going to do now, folks, is we're going to collect like terms, if you will, or simplify sums and differences of radicals. Okay, so simplify like terms. For example, if you had 3x minus y plus x, well, what would you get? Well, that would equal 4x minus y. In similar fashion, what if you had 3 root 2 minus root 5 plus root 2? Well, you can see right away, you can't add root 2 and root 5. They're not like terms, right? So if you look over here, your like terms were 3x and x. Well, similarly, over here, root 2 and root 2, those are your like terms. And if you look at this, this means 1 root 2, right? So altogether, you've got 3 root 2 plus 1 root 2. So that equals 4 root 2 minus root 5. And that's as far as you can go. So that's called simplifying radicals when you're adding and subtracting. And that's a nice simple one. There are more complex ones. What if we have one like this? What if we have 6 root 18 plus root 5 minus root 32. Sorry, folks. Minus root 32. So what I want to do here is, let's see, same sort of deal. I've got to simplify first where I can. So 18. 18 breaks down into root of 9 times root of 2 plus root 5. Now what about root of 32? Well, that's the same thing as 16 times 2. So that's minus root 16 root 2. Now we can start to simplify this a little bit more. Root of 9 is 3. 3 times 6 is 18 root 2 plus root 5 minus 4 root 2. Because the root of 16 is, the root of 16 right here is 4. Well, now do we have any like terms? I think we do. There's a root 2 and there's a root 2. So now we add the coefficient out front. So that becomes 18 minus 4 is 14 root 2 plus root 5. And we're done. And the last thing we can do is multiply. And for that, I'm going to direct you to look at your textbook. And there are some examples on how you expand through radicals. I hope that helped, folks. Hi, folks. Along here.